In this example, we're trying to determine how much force do you need this value for P to keep this block static on this inclined surface. So let's say this is inclined at 30 degree. This block weight is 1,000 pounds, and then the friction coefficient between the surface and the block is 0.2, for example. So one situation is we're trying to push really hard, and we almost trying to it will almost try to go up. So the language used here is called impending motion towards upward direction. So impending up, so trying to go, about to go up. In that scenario, the friction force is going to act to the downward along the surface, and then always normal force act perpendicularly to the surface. And then we can resolve this W now in both in this direction, the surface direction, which will be and then also the perpendicular to the surface in this direction. So if this is 30 degree, that will be 30 degrees C. So this perpendicular component would be 1,000 cosine 30 degree, and then the parallel to the surface will be sine 30 degree. So impending up, while it's trying to go up, it is still static just to initiate the motion. It is still static. So then the summation of y perpendicular to the surface direction. So here we are assuming this is our y, and then the surface direction is our x. So along the surface x, perpendicular y. So if you do summation of Fy is equal to 0, we can write plus n, normal force, always perpendicular to the surface, and then we have minus 1,000 cosine 30 degree. That's the value for the weight perpendicular to the surface, and then P doesn't have any component because that's 90 degree parallel to the surface. If you do this, so then the normal force is, I found, 866 pounds. So then if you can calculate the friction force, which is the friction coefficient times the normal force. Assume the friction coefficient is 0.2 times that normal force, 866. So the friction force can be calculated as 173 pounds. Now if you do summation of Fx is equal to 0, that will now give us to calculate that P. So P is going upward, so that's plus P, and then minus 1,000 sine theta, the weight component of the weight along the surface downward, and then we also have the friction downward. So because we are trying to go up, so then minus F, everything summed to 0. So then P minus 1,000 sine theta plus friction force 173 we calculated. So the value for P I calculated 7673 pounds. So this is the amount of force needed impending upward motion, impending up. Now let's calculate how much does it take just to keep or prevent falling. So in that scenario, the block is trying to move downwards. So then the friction force is going to act upward. So that's the only thing is going to change. But everything is stay same. So the summation of x situation is going to change. So if you write summation of x is equal to 0 now, that's going to be plus P, again going upward, if friction force going upward, minus the component of the weight, 1,000 sine theta, that is going downward. So then P plus 173 minus 1000 sine 30 is 500 is equal to 0. So P, that will be 327 pounds force just to keep falling these objects. If we apply just 327 pounds here, then this 1,000 pound will not slide down. It will just about to slide down, but it will still be static and stay there. So if you look at these two forces, this is where the object will be rested. If we apply this 327 and 673, if we apply force in between these two numbers, it will stay rest on that surface. However, if you look closely, this friction equation, either this one or this one. So if you look closely, P plus F, the 1,000 sine 30 is 500, is equal to 0. So if you apply 500 pound force exactly, then the friction force is going to be 0. What that means is, if we apply anything more than 500, it will impede upward direction. If you apply anything less than 500, it will start impede downward direction motion. So if you apply 450, then it start to slide down. Then the friction force direction is going to change accordingly. If we apply, let's say 600, which is more than 500, or 550, anything more than 500, even 501, then this will impede upward direction. So the friction force is going to act downward. So if you are asked to calculate that what's going to happen if you apply 450, then you assume it's going to slide down, impede downward. However, if you are asked to calculate, let's say, what happened if you apply 550, you assume it's going to impede up and do all your calculation accordingly. And there may be a question asked something like this: for what value of force it will neither impede upward nor sliding down? So that would be the 500 pounds in this example. It's going to change based on the angles and the weight, because as you can see, 1,000 sine theta, that is what is actually determining whether it's going to impede up or impede down.